Yeah, we have two developers working side by side. It's the first one is Claude, whatever the newest model. I forgot the name. And ChatGPT 01. And Claude didn't finish the code because it timed me out. It says Claude response was limited as it hit the maximum length allowed at this time. Well, okay, yeah, fair enough. I mean, it's 485 lines of code, but then GPT-01 is able to generate the whole code. So Claudette, keep it up. And this is what we have at the moment. It's an EMG hand simulation tool. Those meant to be fingers. They look like sausages. Well, I mean, fingers do look like sausages. I mean, yeah, this is a hand. And this is a demo in the beginning where I'm not moving it, but you can move each finger yourself if you like, and it will show EMG recorded from these two electrodes positioned on the wrist. I'm trying to improve the code a bit before we are publishing it. Yeah, and we have two versions now. Which one do you like better? Well, ideally there will be an option to split the two signals into red and blue, left and right. So this is the baseline. It does some baseline noise. And you can move each finger. So the difference between the pinky, you get more blue artifact than red, and if you move the index finger, you have more red than the blue. So that's pretty much all it does. We'll keep it pretty basic. Yeah, we have the two versions. Make sure there are no errors. Now on wider screen, did you do anything on I did ask you to, didn't I? And it thought for a whopping 14 seconds. Okay, can I actually talk to the code quickly? We are live streaming as well.
Sure. What do you want to ask or adjust in the code? Keep it quick, and I'll help immediately.
Okay, so the fusion of the two waveforms looks good. That works really well. However, I'm pretty sure I also asked to make sure the page works well on horizontal and vertical screens as well. So how would you go about that quickly?
To make the page work well on horizontal and vertical screens, I'd adjust the layout and scaling of the elements using CSS Flexbox for responsiveness. Specifically, 1. Ensure the dot container adjusts its width dynamically using percentages and max width for larger screens. 2. Use the viewbox attribute in the SVGs so they scale proportionally. 3. Add a media query to change the layout to a single column format on narrow, vertical screens, stacking the hand diagram and waveform chart vertically. Would you like me to tweak this in the code snippet?
Hey, okay, that sounds good, but currently it's only stacked vertically, but yeah, we would like on wider screens to have the hand and the waveform side by side, and maybe actually on wider screens, if there is enough space, we would like to split the the two waveforms into separate charts. But if there is no space, like on a narrow screen, when the two boxes are stacked vertically, we can then merge the two waveforms together. What do you think?
That approach sounds spot on. Here's how I'd implement it. On wider screens, use a flex container to place the hand diagram and waveform charts side by side. Dynamically check the available space with media queries or JavaScript. If there's enough width, separate the waveforms into two charts. Otherwise, merge them into one chart for narrow screens. Add logic to toggle the combined or split waveform display based on screen size. Do you want me to show how that can be done quickly with a mix of CSS and a small JS tweak?
Yeah, also I want to make sure that when on a wider screen that the white space, the empty space around the hand is being minimized. Can we do that as well?
Yes, we can fix that by setting flex grow for the hand diagram and waveform sections when side by side. This will ensure they expand proportionally to reduce empty space. Additionally, we can use padding or margin adjustments to shrink the white space directly around the hand on wider screens. Would you like me to merge that into the solution?
Hey, can you regenerate the whole script, the whole code without any actually? Shall we split? So currently the code is almost 500 lines. Shall we split it into separate CSS, HTML, and JavaScript files?
Yes, splitting it into separate files for CSS, HTML, and JavaScript is a great idea, especially for maintainability during live streaming or development. Here's how I'd organize it. 1. HTML, the structure and content. 2. CSS, the styles including responsive design tweaks. 3. JavaScript, the logic for waveforms, responsiveness, and interactions. Would you like me to regenerate the code split into these three files and ensure it handles all the responsiveness features you just mentioned?
Okay, we generating the code. Yeah, I'm not sure entirely how to use Claude. It keeps timing out. Maybe once we split the code, Claude would be able to be useful again. Yeah, so ChatGPT, the O1 reasoning model was thinking for 8 seconds, apparently meant to be PhD level. Code separation, ensuring responsive design, mapping the approach. Yes, it meant to generate 3 separate files, crafting the layout, minimal white space around the hand. Yeah, that would especially be useful on wider screens. Okay, currently we have these two versions. They are standalone. Okay, did it actually generate the whole thing? That's JavaScript, CSS, HTML. Okay, so start with the HTML. So now it's only 100 lines of code, and it should be calling a style CSS. Okay. Okay, we have the HTML, have the styling. Okay, that looks better. Oops. Yeah, on wider screens, it does adjust pretty well, but yeah, there's a room for improvement. And we obviously need the JavaScript. Okay, we actually have it running. We have the instructions, theory, future directions. Perfect. Okay, so it's working really well on so when vertically stacked components, yeah, it's really good that the waveforms are merged together into one chart. But then on when the screen is wider, the different elements are stacked horizontally, which is great. But then we would like the hand to be on the left as it is, but then the electrode 1 and electrode 2 be stacked on the right.
Got it. To make the hand stay on the left and stack the two electrode charts vertically on the right when the screen is wider, we can tweak the CSS. Here's what we'll do. 1. Use a flex container for the wider screen layout. 2. Make the hand section take up the left column and stack the two charts in a vertical column on the right using a nested flexbox. 3. Adjust spacing to ensure it looks balanced. I'll modify the CSS for this behavior. Here's the updated layout logic.
Okay, so modify the CSS, specifically the media query. The hand section. Do we just replace? No, we do not. Let's do it again. Okay, we have the separate shots. This hand section. Okay, let's do it again. Wait, we're missing something. We're missing the combined shots. Okay, there's another problem. Okay, we can get rid of that. But there is another problem. Okay, it's working really well now, but there is one
You're
problem.
welcome. Let me know if anything else needs tweaking.
Yeah, there's one problem where when changing from to a wider window, the signals are not actually running.
This happens because when switching layouts, the JavaScript managing the signals, whether merged or split, doesn't properly reinitialize for the new layout. We can fix this by adding a resize event listener to detect screen changes and reinitialize the EMG waveforms. Here's the fix. Update the JavaScript script.js. You can see the code in our conversation history. Why this works. 1. The initialize visualization.
Yeah, that's fine. I don't need to know why it works. I just need to work really. So it would be in JavaScript. Oops. I might need. I'm hopeless at coding. Yeah, we need to regenerate the whole thing. Because I don't know how to integrate properly, which is unfortunate. Yeah, we have the function. Okay, then we have the class. Yeah, we stuffed up the order of things, didn't we? Okay, now it's working. Yep. Very nice. Thank you very much. Yeah, so this demo is not great. Yeah, I have the baseline. Yeah, you can keep flexing the pinky and the index finger to see the difference. The demo mode can be slowed down a bit. Right, this is actually better. We did it ourselves. we didn't need the robot to modify the code, so maybe. Yeah, no, we still need robots. And check on. Yeah, the demo is still running, so you can see them horizontally or side by side. They're stacked up. That's very, very, very nice. It's so nice. I'm thinking a GIF out of it. So eventually there will be a link to it on the landing page. On a critical and fun review of this thing.
It looks like the layout is transitioning nicely between the stacked and side-by-side configurations. On the widescreen, the hand image is placed on the left, and the two waveform charts are displayed on the right, arranged vertically. The electrode indicators are clearly visible, and the charts look crisp against the light background grid. The smoothness of the line drawing suggests the signals are being updated properly. From a visual standpoint, the design strikes a good balance between clarity and simplicity. The spacing seems comfortable, with enough room to appreciate both the hand diagram and the signal charts without feeling cluttered. When live streaming, your audience would see a dynamic and well-structured interface that effectively demonstrates how muscle activity might influence EMG signals. One possible critique is that the labels, particularly the E1 and E2 inside the wrist area, may be a bit small and could blend slightly into the background. Ensuring that their text contrasts more sharply with the skin tone or providing a subtle outline could improve readability. Another consideration might be adding a very slight padding or a distinct border around the charts to set them apart visually when the page is viewed in bright conditions or on a screen with lower contrast. Overall, this is a very effective demonstration tool. It is intuitive, pleasing to the eye, and seems quite stable now. The concept of switching from a single combined waveform to two separate charts depending on screen width is a clever, adaptive design choice. With a little more polish on labels and perhaps some fine-tuning of spacing, this can easily stand as a polished educational resource for people interested in EMG signals. Here's the updated description for the bottom of the page. How the tool works. This tool simulates the electrical muscle activity recorded by electrodes placed near muscles controlling hand movement. On narrower screens, it displays the hand above a single combined chart containing both electrode signals to conserve space and maintain a single screen experience. On wider screens, it adapts by placing the hand diagram on the left and two separate electrode charts stacked vertically on the right, providing a more detailed view and reducing empty space around the hand. Clicking a finger triggers a brief change in its position and a corresponding increase in the recorded signals, illustrating the connection between muscle movements and electrical activity. Theory behind it. The concept behind this simulation is rooted in electromyograms, EMGs, which capture the electrical signals produced by muscles as they contract. Although this demonstration does not represent actual medical data, it provides an intuitive, accessible introduction to the principles behind EMG recordings. In real world biomedical research, EMG signals can be used to investigate neuromuscular function, guide physical rehabilitation strategies, control prosthetic devices, and even develop new interfaces for interacting with technology. Future directions. Looking ahead, this tool may incorporate a wider range of biomedical signals, such as electroencephalograms, EEGs, and electrocardiograms, ECGs, expanding its educational potential. The goal is to continue refining the interface so it remains simple, accessible, and fully contained in a single screen, all without relying on proprietary or closed source platforms. You can follow the ongoing development and experimentation on the Bionic House YouTube channel and on the website, where feedback is always welcome. Support through Patreon would help enhance the range of features, improve visualizations, and keep the project free and open source.
Yeah, I'm just trying to release this tool so it's available for you to play with. There will be a link on the landing page. And now we're just fighting with CSS. But if you have any questions about any of the other tools on the website, do let me know. Yeah, we need relevant stuff for this specific web application. Don't need any of the other rubbish. Hey, can we get the robot to fill this in? Will it just understand? Yes. well, the name is EMG gesture. Yes, we need a thumbnail for this. Right, we forgot something important. In the body, we have this header. Oh, no, actually, this one. This one we only have on the landing page. So eventually we'll have a link. And this tool here, this Venn diagram, it's not quite clear when you're loading it that it's actually dynamic content. We probably have to, well, we don't have to anything, but we might want to look into animating this. So when loading the page, it might, yeah, do this without clicking on the mouse. Yes, same as the EMG, we have the demo. So yeah, demo mode. Tel event. Yeah, if you have any specific questions about any of the tools currently available on the website, do let me know. Yeah, for this one, for example, I was thinking it's better to generate the more useful knowledge graph diagrams as opposed to those silly images that ChatGPT generates. Some of them are better than others, but generally, yeah, not so great. So let me know what you think. For this one, we still need the image. It's something like this will be nice. Yes, we're only using open source tools. Well, except ChatGPT and Claude, that by the way keeps timing out on us. It's not very useful, I would say. Yeah, this one's not very clear what's going on in a static image, but well, that's also why you will have to click on it and see what it does. And this one's called EM gesture, EMG gesture, EM gesture. We are mostly using JPEG. know if this will be in a static folder or not. The image for it. And it's not deployed yet because we need to redeploy the site. We haven't done it in a while. So it will be down for a short time. Yeah, there we go. There we have it. There we have it. quickly because we forget the image.
Exploring muscle signals with a simple interactive tool. What's next for EMG in education? Muscle activity produces fascinating electrical signals that can be captured and visualized through electromyography. I've been working on a browser based tool that allows you to simulate this process and see real time waveform changes triggered by hand movements. Check it out here bionichaos.com/as.com/. On narrow screens, the tool consolidates the signals into a single combined chart for simplicity, while on wider screens, it adapts by splitting the signals into two distinct charts stacked vertically, an approach that reduces empty space and improves detail. The concept is straightforward. Clicking on a finger bends it and increases the corresponding EMG signals for two virtual electrodes. While this is a simplified simulation, it invites anyone, regardless of their background, to explore the relationship between muscle movement and electrical signals in an intuitive way. But this raises some interesting questions. Could tools like this be used to better explain EMG and similar biomedical signals to non-experts or students? What role do interactive open source visualizations play in making biomedical science more accessible? How far can we push browser based tools to integrate real world data or sensors without losing simplicity? I'm thinking of expanding this to include EEG, brain signals, or ECG, heart signals. I'd love to hear your thoughts. What features would you add to make this tool more engaging or educational? Do you see potential for such tools in other areas of biomedical education, research, or even entertainment? Let's spark a conversation. Feedback, ideas, or critiques? Let's hear them. Explore the tool. bionichaos.com/Last year biomedical engineering, EM
Yeah, go check out the website. Let me know what you think. We have a bunch of other tools in the works. Go over them quickly. Yeah, this one's search for biomedical data types. It's called Biomedical Data Type Explorer. So let me know if you find something like this, Andy. We also have another Venn diagram. I don't particularly like it because it opens another window. Yeah, we could make it better. Yeah, this one is better because it just stays in the one window. I don't like this one because it then loads a separate window page. So not ideal. Yeah, this body map. Yeah, the robots currently a bit hopeless at generating 2D, let alone 3D models. So we'll have to. Yeah, I don't know if you have ideas how to improve it. Do let me know. This one will explain body parts. This one meant to have a hover over as well, but I think it's actually a bug because the tip appears under that window. So it's not very nice. Yeah, I like the information tips. They're quite nice. What else we've got? Yeah, we got this training, another data set. This breast MNIST, but yeah, will be eventually similar to the EEG seizure detection project, where you could scroll through the data and see the results of the training. So in this case, you will have two types of X-ray images. But yeah, this will need more explanation. Yeah, making our own chatbot. There's a bunch of games that we're making as well. Yeah, making tool. This one will have to actually test it on your mobile. It might be able to fetch the data from the sensors on your device. This will be an ongoing project. Yeah, we have the EMG gesture that we just published. Yeah, we have this face mask thing, but yeah, we had some trouble with it. So we might let it go for now. Have to start it from scratch. The idea was to have your face on a webcam and overlaying a mask over it. That you can draw yourself. Yeah, and a bunch of other things will go over them. And next time, oh, we also have this jazz generator. Might be loud, beware. The percussions, it doesn't work at the moment. Yeah, I think we broke the randomness from memory. A tempo works, not duration. They work as well. Yeah, there was some other parameters that we were considering. It will show you the frequency for each component that it's currently playing. There's meant to be a melody to it as well, but yeah, we'll see. Yeah, this will also be an ongoing project. Yeah, it has JSON files with different scales, different melodies. Yeah, an index HTML of 130 line and a script JS of almost 270 lines of code. Yeah, obviously not something you would be listening to right now, but yeah, we'll try and improve it. It will be an ongoing project because we're interested in music, and we're also interested in synthetic music because you can actually see how your brain responds to the different elements or different characteristics within the music. So that's another project we've got, and we got something else on. Yeah, on EMG, that's just using your mouse to generate to mock up. Yeah, it's called Mayo Mock, and yeah, this is just moving the mouse. Also should work on touch screen as well. I'll try and make it more realistic and yeah, I'll probably look at this one next.
The Enhanced Jazz Music Generator interface is functional, and it integrates tempo, note duration, scale selection, and various instruments, including lead, bass, percussion, and chords. The JSON data specifies the frequency ranges for scales, blues, major, minor, while the JavaScript dynamically loads and generates notes based on user inputs, randomness, and timing. The visualization dynamically updates the frequencies played. Everything looks streamlined. What would you like to improve or tweak further? The Enhanced Jazz Music Generator combines interactive controls, audio synthesis, and real-time visualization to create an engaging music tool. Here's the overview. 1. Core Logic. The app loads predefined musical scales and melodies from JSON files. It uses randomness and user-selected parameters, tempo, duration, scale, to generate dynamic jazz music. 2. Instrument Management. Users can enable or disable lead, bass, percussion, and chords, each mapped to SoundFont instruments. Percussion sounds include variations like standard, Latin, and brush. 3. Real-time playback. Notes are played using SoundFont Player and visualized via a time series plot. The audio engine ensures instruments play in sync, adapting to randomness and timing constraints. 4. User interaction. Sliders, drop-downs, and buttons allow users to tweak playback parameters and instrument settings. Debug mode provides insights for developers, displaying playback details. 5. Visualization. Frequencies of notes played are dynamically displayed in a canvas as color-coded time series graphs for each instrument. The app is modular, responsive, and interactive, allowing for flexible jazz generation with minimal dependencies and smooth performance.
Yeah, that's interesting. The canvas is still there. It's now in projects. So if you want to use the canvas, you actually have to start the project. So that's interesting.
The JavaScript code has been updated to address the issues with randomness, debug toggle, and percussion functionality. Let me know if you need further modifications or additional debugging suggestions.
And you have an option to turn the canvas off. And it's responding in the chat. Can you select the model? A different model? It doesn't look like. Let it finish generating. The debug information is empty. Yeah, we need to go over the code again step by step. Well, currently the debug information is not showing anything. Can we actually make sure it's showing anything useful? Yeah, the toggle button does work, but the display for the debug information at the bottom of the page is not actually displaying anything. Now the percussion still not doing anything. Lead, bass, and chords do work okay. The randomness slider is, I'm pretty sure, not doing anything, because we expect it to vary the tempo and the note duration in random fashion. So when 100% randomness, it should really go for it. And when low randomness, it should be more loungy type of jazz. Can you, before changing the code or generating any code, just look at the code and explain what's going on?
Sure. Here's a simpler explanation of what's going on. 1. Debug toggle. The debug button does turn the debug section on and off, visible or hidden, but nothing is being added to the debug box itself. It's empty because the program isn't writing any information into it, like the notes being played or other details about what's happening. 2. Percussion. The code tries to load and play percussion sounds, but it looks like the sounds aren't actually getting loaded or played. This might be because the percussion patterns in the data don't match the actual instrument sounds available, or the program isn't handling them properly. 3. Randomness. The randomness slider only changes how the program picks which notes to play. It doesn't affect the speed, tempo, or how long the notes last, duration. This is why increasing randomness doesn't create the wild, dynamic jazz you were expecting. It's just making the note choices more random, but everything else stays the same. Let me know if that clears things up or if you'd like more details. Yes, the JavaScript code needs to be updated to address the following. 1. Debug toggle. What's missing? The debug section is empty because the code isn't writing any useful information into it. Update needed. Add functionality to populate the debug section with live information, like the current tempo, randomness level, notes being played, and instruments enabled. 2. Percussion. What's missing? Percussion sounds are likely not playing because the patterns in the data might not match the expected instrument sounds. The percussion sounds aren't properly loaded or mapped to playable instruments. Update needed. Verify that the percussion sounds are loaded correctly and mapped to patterns from scales.json. Ensure the percussion playback logic triggers correctly when enabled. Half 3. Randomness. What's missing? Randomness only changes which notes are selected, but it doesn't affect tempo or note duration, which are key for creating dynamic, unpredictable jazz. Update needed. Extend randomness to adjust tempo and note duration dynamically. At 100% randomness, vary both wildly to create a more chaotic sound. At lower randomness, make the tempo and note duration smoother and more consistent for a loungy feel. Summary. We need to 1. Write real-time debug info to the debug section. 2. Fix percussion to ensure it plays correctly. 3. Expand randomness to affect tempo and duration, not just note selection. Let me know if you'd like me to implement these changes step by step.
Yeah, so it seemed to work okay now. We're testing by... there's still nothing in the debug information, which I asked for several times already. But now the randomness seemed to work. So when we have randomness 0, it's following the frequencies and the amplitude to the tempo and note duration. Should be following a certain pattern. Yeah, percussion still doesn't do anything. The controls for it doesn't do anything. And but the good thing is now when we set randomness to 100%, we can actually see from the chart that the music, so-called music, is more randomized, but I can't really hear it though, so I'm not yeah, we really need the debug information going. Well, because currently when randomness is set to not 0, we were kind of expecting the tempo and the note duration to keep varying, the slider actually moving around, but it doesn't actually happen. So if we can check the entire code, can you just respond without generating any code? Just give an overview of what's going on.
Let's break this down step by step based on what you've observed. 1. Debug information. What's happening? The debug section is still not showing any information, despite being toggled visible. Why? Although the toggle function works, the actual data, like tempo, randomness, active notes, etc., isn't being updated or written into the debug section, debug info. The code is missing periodic updates to display this data. Current state, the debug panel is visible but remains empty because nothing is being logged or displayed dynamically. 2. Randomness. What's happening? When randomness is 0%, the tempo and note duration don't follow a dynamic pattern. They stay fixed, which is expected to some degree for low randomness. However, randomness at 100% is behaving better. The visualization shows a more randomized distribution of notes, so the note generation part works as expected. Why? The randomness logic for note selection is implemented correctly, but it doesn't actively adjust tempo or note duration to follow a meaningful dynamic pattern at lower randomness. The slider isn't tied to moving these values dynamically. Current state. Randomness works for frequency selection, but doesn't yet apply smoothly to tempo and duration. Percussion. What's happening? The percussion still doesn't play any sound, and the percussion controls don't do anything noticeable. Why? The percussion sounds may not be loaded properly due to missing or mismatched mappings between percussion type and the available instruments. The playback loop for percussion might not be triggering correctly. Current state. The percussion system is non-functional because either the sounds aren't being loaded or the logic for triggering percussion isn't working. 4. Tempo and note duration. What's happening? Tempo and note duration remain fixed even when randomness is 0%. They don't follow any noticeable pattern or dynamically adjust with the slider. The randomness logic currently doesn't affect these values, and there's no code to dynamically adjust the tempo or duration in sync with randomness or other patterns. Why? The randomness slider is only influencing note selection and not applying variations to tempo or note duration. Current state: tempo and note duration are static and unaffected by randomness, even though they should adjust dynamically. Summary: 1. Debug information is visible, but remains empty because no data is being logged or displayed dynamically in the debug panel. 2. Randomness partially works for note frequency selection, but it doesn't yet affect tempo and note duration. 3. Percussion controls and playback are non-functional due to likely sound loading or logic issues. 4. Tempo and note duration don't follow any pattern when randomness is low or adjust dynamically at high randomness. Would you like me to focus on debugging one issue at a time or prioritize fixing specific parts like the debug info or percussion?
Do you think we should have separate randomness sliders for the node selection, which currently is working, if I understand correctly? Correct me if I'm wrong. But then also have a slider for each tempo and node duration, which will randomness slider, which will vary each one of those individually. Later we could have some sort of crazy mode, which turns all the randomness to 100%. So we'll have, so what do you think of having multiple randomness sliders?
Yes, having separate randomness sliders for note selection, tempo, and note duration is a great idea. Here's why it makes sense and how it could improve functionality. Why separate randomness sliders are beneficial. 1. More control. Individual sliders allow finer adjustments. For example, you might want highly randomized note selection, chaotic melody, but smoother variations in tempo and note duration, a loungy feel. Or vice versa, randomize tempo heavily for dynamic rhythm changes, while keeping note selection predictable. 2. Flexibility. Users can tailor the randomness to their preference, creating a wider range of musical outputs. Controlled, smooth jazz at low randomness. Completely chaotic jazz at high randomness. Having independent controls for tempo, duration, and note selection allows exploration of different combinations. 3. Simplified testing. Isolating randomness for each component makes it easier to debug and test. You can check if tempo randomness works without being influenced by note selection randomness. You can test note duration randomness independently to confirm it behaves as expected. 4. Future crazy mode. A crazy mode toggle can simply set all randomness sliders to 100%, creating full chaos. This is easier to implement and understand when the randomness sliders are already separate. How it would work. Randomness sliders, note selection randomness, controls how notes are picked from the scale. Tempo randomness adjusts how much the tempo fluctuates. Note duration randomness controls variations in the length of each note. Example behavior. Low note selection randomness. Notes follow a predictable scale. High tempo randomness. The speed of playback varies dynamically. Medium, note duration randomness. Notes have slight variations in length for subtle humanization. Current state of randomness. You're correct. Note selection randomness is currently working. It randomizes which notes are picked from the scale. Tempo and note duration don't yet vary with randomness because they're not connected to the randomness logic. Do we need separate sliders? Yes, because it keeps the design modular and easy to expand. It gives users full control over each component. It simplifies adding features like crazy mode in the future. Let me know if you'd like to proceed with this approach, and I can help you plan or implement it.
Yeah, you might need a hearing test after listening to this music, which luckily we also have on the website. This is what's mine doing at the moment.
The JavaScript code creates an interactive jazz music generator that uses randomness and real-time control to produce dynamic musical compositions. It starts by setting up a web audio context to manage sound playback. Instruments, scales, and randomness settings are loaded and managed through a modular structure, ensuring flexibility and customization. The code defines multiple instruments, including lead, bass, chords, and percussion, each of which can be enabled or disabled based on user input. The visualizer component is responsible for graphically displaying the generated music. It maps frequencies to a canvas in real time, creating a dynamic visualization of the notes being played. Each instrument has its own color-coded line in the visualizer, which updates every frame to show frequency changes over time. This visual feedback adds an engaging layer to the application. Randomness is a core feature, and it is applied independently to note selection, tempo, and note duration. The code uses sliders to control the level of randomness for each parameter. A low randomness setting creates predictable, loungy jazz, while a high randomness setting generates chaotic, free-form music. Users can also enable crazy mode, which sets all randomness sliders to their maximum values, creating a completely unpredictable musical output. The percussion system is designed to generate rhythmic patterns based on selected scales and instrument types, such as standard, Latin, or brush percussion styles. These patterns are combined with lead, bass, and chord melodies to create a cohesive jazz performance. The percussion instruments are loaded dynamically, and the rhythms are visualized in real time alongside the other instruments. Debug information is provided in a dedicated section where users can view real-time updates on parameters such as tempo, note duration, and randomness levels. This information helps users understand how their settings influence the music and aids in debugging during development. The debug panel is dynamically updated during playback, offering insights into the inner workings of the application. The playback loop integrates all these components, ensuring that tempo, duration, and note selection are adjusted dynamically based on user input. Notes are generated from predefined scales, and randomness influences their selection to ensure variety. The tempo and duration are recalculated for every loop iteration, creating subtle or dramatic changes based on the randomness sliders. The code also includes future-proofing elements, such as support for user-customized instrument configurations and plans for downloadable music files. Overall, this application merges technical sophistication with user-friendly controls, offering an engaging and versatile tool for creating generative jazz music. It provides flexibility for casual users to explore jazz sounds and for developers to experiment with advanced musical algorithms. The code shown in the Visual Studio Code Editor focuses on managing the initialization and event listeners for the Jazz Music Generator's interface. Here's a continuous explanation of what's happening. Initialization of elements. The initialize elements method ensures all necessary HTML elements are linked to the JavaScript logic. It loops through a predefined list of valid instruments like lead, bass, percussion, and chords. For each instrument, it sets up two main controls. 1. Toggles, checkboxes that enable or disable the instrument. 2. Note displays, elements where currently playing notes are shown in real time. If these elements exist in the HTML, they are linked to the elements object for further use in the program. This setup simplifies referencing them later for control or visualization. Instrument loading. The load instrument method asynchronously loads instruments like piano, bass, or percussion using a sound font library. It checks if an instrument is valid and not set to none. If valid, the sound font library loads the instrument and it is stored in a sound font player's map. This allows instruments to be reused without reloading, improving performance. Errors during the loading process are logged for debugging purposes. Event listeners setup. The setup event listeners method defines interactions for every user control, including 1. Instrument selection. When the user selects a new instrument, the corresponding sound font is loaded dynamically. 2. Start and stop buttons. These buttons trigger playback or stop the music generator. 3. Debug toggle. A button toggles the visibility of a debug panel that can show detailed real-time information. 4. Crazy mode. Clicking this button sets all randomness sliders, tempo, duration, and note selection to 100%. This creates chaotic and unpredictable musical output. 5. Sliders. Event listeners update the values displayed on the UI as users adjust the sliders for tempo, note duration, note selection randomness, tempo randomness, note duration randomness. 6. Percussion type. The drop-down for selecting percussion types, like Latin or brush, triggers reloading of percussion instruments. Summary. The code shown is responsible for linking the user interface with the core logic of the Jazz Music Generator. It dynamically updates UI elements, handles user input, and prepares instruments for playback. By structuring event listeners and initializing elements up front, the application ensures smooth interaction and responsiveness. Here are clear, step-by-step instructions for another developer to fix the debug information and ensure it updates dynamically in the code. Instructions to fix debug information. 1. Identify the debug panel. Locate the debug info element in the HTML, which serves as the container for the debug data. Ensure it is visible and properly toggled using the Toggle Debug button. 2. Create a centralized debug update function. Add a function that gathers the following real-time values and updates the hash debug info content. Tempo, BPM. Note duration, seconds. Randomness values. Note selection randomness. Tempo randomness. Note duration randomness. Active instruments, lead, bass, percussion chords. Percussion type, standard Latin brush. For active instruments, loop through the toggles checkboxes and include only those that are enabled. 3. Trigger debug updates on UI changes. Update the debug information whenever the user interacts with the following sliders and dropdowns. Tempo slider, note duration slider. Randomness sliders for note selection, tempo, and duration. Percussion type dropdown. Add calls to the centralized debug function inside the onInput or onChange event listeners for these controls. 4. Update debug information during playback. Integrate the debug update function into the playback loop. This ensures the debug information reflects any real-time changes in tempo, note duration, randomness, and instrument states as the music plays. 5. Verify debug panel visibility. Ensure the Toggle Debug button works correctly to show or hide the debug panel. Test that the content dynamically updates when visible. 6. Test and validate. Check the debug panel for correctness. Adjust sliders, tempo, randomness, note duration, and confirm the values reflect the current settings. Toggle instruments on and off, and ensure they appear or disappear from the debug output. Change the percussion type and verify it updates correctly in the debug information. Run the playback and confirm that real-time changes like tempo and randomness adjustments are reflected in the debug panel. Hash outcome. After completing these steps, the debug panel will display all relevant real-time values, update dynamically when user inputs change, reflect current playback states, including active instruments and percussion type. Let me know if further clarification is needed.